Hello everyone. Today I'm going to give you the project report of bird species observation analysis. The main goal of this project is to understand how each and every environmental conditions is affecting the bird detection patterns. This is the problem statement and the business objective. And these are the libraries that I've used to create the project. And I've been using two data sets for the forest dataset and the grassland dataset, and each and every sheet is considered, and it is in an Excel sheet format. I have included all the sheets using the concat function. I concated both these data frames into a single data frame. Here, as we can see, there are multiple rows and columns, 8,546 for all the combined sheets, 8,531 for all combined sheets of grassland. I've included a new column to distinguish between two datasets in the combined dataset. This is the head of the combined sheet. As you can see, they have included the habitat, and combinedly I have 17,000 rows. This is the information about the combined dataset, all the columns and all the number of rows that are available. These are the number of duplicate rows that are available in the combined sheet. This is around 1700 duplicate rows. These are all the null values that are available in the total sheet. I'm visualizing all the missing values that are available in the sheet. As you can see, there are few NaN values in the rows. I'm dropping the duplicate values because that they decrease the accuracy of the analysis. After deleting these are the number of rows that I have, 15,000. This is about my data set and all the columns that are available. And I'm describing all my data set into values, the count, mean, etc. And this is about my variables, all the different names, all the different columns that are available, and what I've created, the habitat. These are the unique values that are available in the dataset. And coming to the data wrangling, these are the data modifications that I have done to the dataset. I have I have rounded the humidity column decimal points to 2, and also temperature. And I have combined the site name empty values with the first name with the same similar to the admin unit code to not leave them as empty values. I have replaced null values from various columns to 0. As you can see, with subunit code is 0, and acceptor TSN is 0. NSP taxon code I've replaced with 0. Taxon code I've replaced with 0. And previously observed I've replaced with the mode of the column, and also IDM method I've replaced with the mode of the column. And I have introduced a new column as seasons to segregate into different seasons where observers saw had their bird watching results. After performing these, I don't have any null values. I have handled all the null values with either handling them with zeros or replacing them with respective results. And I have downloaded the clean dataset to you to show and import it into the BI platforms like Tableau. I have used Tableau. These are all the manipulations that I've told you, and what I found in the insights. The first chart is the uh, bar chart to show the count for the habitats, the unique bird counts that I have found. And the second chart is the top 10 bird counts that are observed in the forest and grassland combinedly. The third chart is the sex distribution of the birds. Mostly, as you can see, that there are mostly undetermined, and also those in forest. We cannot find any male female value counts. And the fourth chart is the observer count by habitat. As we can see, Elizabeth Oswald observed more, around 3,500 in forest, and also she's leading in grassland as well compared to all these three observers. And the fifth chart, we have observer versus the interval length, how much time they search for, keep it for the bird watching with. And I have segregated that with the habitat, the forest and grassland. As we can see, mostly we can see that the uh, 0 to 2.5 minute interval length is having more preference, and 7.5 to 10 minute is the least used interval. And coming to the sixth chart, I have segregated observer versus ID method to identify the bird with, and I'm segregating them to forest and grassland. As we can see, most of the birds are identified by their singing identity method. Be it be it forest or grassland, mostly singing is observed to determine the bird. These are the top 10 birds under each sky condition. As you can see, Carolina wren is mostly having visual viewing in the partly cloud. The same with northern cardinal as well. And we can see that blue jay that shows only foggy conditions, and also red-winged blackbird. Field sparrow shows only towards misty. This is the sky condition versus the average temperature and the average humidity. This is the average temperature and the average humidity based on the wind condition. We can see that mostly in grasslands, temperature is higher compared to that of forest, and humidity is more in forest compared to grasslands. And this is the disturbance observation count by habitat. These are the seasonal species that are available, segregated with respect to the habitat. As we can see, in spring we can observe more diversity in grasslands, and in summer we can see more diversity in forests. This is the humidity chart versus the bird count. As you can see, around 70 percentage of humidity we can find more bird counts. And this is the temperature versus the bird count. We can see 22 to 24 degrees, we can see the highest bird count. It is optimal for bird watching. This is the correlation matrix and the pair plot. In conclusion, this is the clean data set. As I've told you, I've created habitat, forest and grassland to segregate two data sets. And as I've told, these are uh, yeah. And coming to the dashboards, I have created multiple dashboards, like KPI indexes, distributions, top observed, and as you can see, I also have filters to show in which month for each and every chart. and dashboard, weather, bird count, habitat, weather, top observed birds, top observed with respect to habitats. These are all the charts and dashboards that I've created, and this is the report. I have concluded everything into one report, and these are the solutions that we can give to the bird watching agencies, and we can have bird watching as a higher impact. These are the few solutions that I have uh, concluded. Implementing tailored ID methods for different habitats for better detection rates, align surveys with high bird activity windows to improve species capture and reduce noise in data. Regular data workshops will reduce inconsistencies and enhance all over data reliability across regions. Design survey to cover all seasons and help forecast biodiversity shifts over time. Use temperature, humidity, and sky conditions to build predictive models that improve the efficiency of survey scheduling. And this is the conclusion for the data analysis for the bird watching. Thank you.